and in some parts it's 2 inches tall. Our goal is for a robot to be able to clear it, and we want a robot ideally that can go over 2 inch tall, but at least to be able to go over 1.5 inch. The problem that we have right now is that the wheels that we have a radius that is between 1 7/8 and 2 inches, and that doesn't work out very well because we also have to have a shaft somewhere that's spinning the wheel, and so then we probably won't be able to clear 2 inch triangles.
So what are your solutions?
So one of them was like having some mounting pieces to clear it, the barrier. And some of our ideas were having the giant like rubber wheels, but we don't have that yet. So we're thinking.
We also had an idea of lowering the banana wheels because we like strafe it. We argue back and forth for a good 10 minutes.
They for some reason, some people like to argue. I was surprised. All right, did you lose? All right. We could put different wheels on, which don't exist yet. We could put tank treads on, which maybe then we don't care if we get them up. There's a couple other solutions we can think about. We can add a third wheel, actually 6 wheels in, right? 3 wheels on the side to kind of give us more oomph. We can also add maybe something that would help you push up off the ground. If you get stuck, last year the team had an arm they kicked out and set them up against the wall, put them up higher so they could get off. They get unstuck. So we could have something that maybe shoots you forward or shoots backwards off. So good work on that. All right, programmers, we gave you a challenge. You come on up, and I'll explain the challenge. You started programming. We also brought you Slim Jim with the new part that we asked you to do something with. Want to tell them all about that? All right.
We had the small robot to go for the little like 13-inch without going over the barrier, and so we were taking that, and we had something called a spinner to go on it to spin the carousel. And so we were making a class for that and working on putting all the methods into the drive room so we could practice different methods. So we had like toggling it on and off at just like a set speed with a button on the pad, and we did the set power based on the trigger, how much you press the trigger down is how much it'll how fast it'll go. And then really we had set so I could do like a random sort of thing, but we kind of were not prioritizing that today. And yeah, we didn't quite finish just the troubleshoots and stuff, but that's what we did. And Vivian can talk about what everyone else did.
What everybody else did was we made methods for motors and servos. So we made like a method for motor and servo, and we activated it with the touch button on the virtual robot. So like if we touch the button, the motor goes forwards, we touch again and backwards, and like that.
Excellent. Great, thank you guys. We had 2 people working on that. Vinny, I call it Slim Jim, is what you guys working on. Come on up. And so I gave you guys challenges like, hey, keep it here, keep it real close. We don't want to take up this room because this is where we want you to take it, or maybe the outtake or something there. So keep it right here. And then you discovered a couple things about that.
So today we were pretty much working on the logistics of this whole thing. We were doing lots of rewiring and adding inverters to stuff. So we were just getting ready to go to the programmers because it needs to be able to start and stop. So we figured the best way to do that would be with coding.
So there was a couple problems you discovered, right? You discovered this was what?
It was too high, so it would have like barely hit the carousel thing. So we had to use a lower thing and then have the motor be lower, so that this could be like at the same level.
And when you lowered the motor, what initial challenge did that create? Now we had a problem. We solved it by lowering the motor, and did it create new problems for you?
Yes, because then it was going to hit up against this wire and also of these wires are going to hit this wheel. So it's just.
We don't want wires get inside chains, right? That's not going to be good for anything. So what do you do?
So we rewired it through some of the holes on this like that. And
Yeah, wire management is important. The other really nice thing they did here, is you can see they added what they numbered this. This is expansion hub EH0, expansion hub 0. That's where it's plugged into. They also gave the requirements right there. Right? They wanted to know what RPM they'd like to have it spin at.
Yep.
No challenge there, right? That's great. So nice work.
So we worked on making like designs for t-shirts, and we worked on like a little bit of strategy. And here's some designs that we came up with after this.
Alright, so we made like a code duck, I guess you could call it. So where we just had all the information about like the different teams in a form of code.
We had like a doc, and it was in front of like a bunch of lines of code. And like the school name inside of the code, and like the team numbers and colors and stuff.
We put these two springs, and then we put like a big screw in here, so we put the spring there. And then, so when you move it like this, it like pushes it out. So then the left one, the medium one, which is only 2 brackets.
And we can also, so you can set this bucket to where you want the cube to go. And without changing what underneath right here. Yes, sir. Say it louder.
The only problem with it is it's not launched.
So we're not launching anything. The whole idea is that we would have a micro switch here, right? And we can see, we can constrain it here, right? And so if it's heavy enough, we will hit the switch. And you'll notice heavy one. If it's not that heavy, we'll lift it up off the switch. Yes, sir. It might.
But we have
So I have to just watch it. But I think we're only going to go for probably a few weeks. It should last a few weeks, but we'll figure out over time if we did it for a few years. You want to suck some stuff up? You want to tell them what you did?
Okay, so we switched out the front flail here and drilled holes in the side of the rectangle thing there. And we made this chain a bit tighter. And we.
So how do you make the chain tighter?
Oh, we added these like wheel things here to push it down.
Sometimes you can call them tensioners, right? And so you can put them on there and then tension to the chain. You see how I make it tighter?
Yeah, it's pretty much all.
You want to see it run? All right, you got it going. Flip the switch, turn it, wait, there we go. So kids, don't try this at home. There you go, you're the way the camera there, you shot. Right here. And the cool thing, they discover that once they get it in, they don't need a lot to keep moving. Is that pretty slick? Alright. Nice work. Is that kind of fun? And this will actually even fit on the knee.